So the video solution of this problem is not available in the NPTEL Gate portal. So I'll be solving this problem. Let's see what this problem is saying. Okay. A right solid circular cone standing on its base on a horizontal surface is of height h and base radius r. The cone is made of a material with specific weight W and elastic modulus E. The vertical deflection at mid height of the cone due to self weight is given by a right solid circular cone standing on its base on a horizontal surface is of height h and base radius r. The cone is made of a material with specific weight W and elastic modulus E. The vertical deflection at mid height of the cone due to self weight is given by. Okay, so we have to find the vertical deflection at mid height of the cone. So the base radius of the cone is r, height is h, specific weight rho g is w, and the elastic modulus is e. If we name the base point as a, middle point as b, and the topmost point as c, then we have to find out the deflection at mid height, that is delta b, this delta b. So the deflection at b will be nothing but the amount by which this BA portion is shortened. Okay, so the amount by which this BA portion is shortened will be the deflection of point B, delta B. Okay, so delta B is equal to delta BA shortening of segment BA. Okay, so before proceeding in this question, let's understand a simpler case, then we will proceed into the asked question. Okay, so we will first consider we are considering a bar of length L which is subjected to a tensile load P. The elongation of the bar due to this tensile load can be found out by this formula NL by AE, where N is internal axial force in the free body diagram. So if we cut a section anywhere along the length of the bar and construct its FPD, then we can find internal axial force. So this FBD will remain in equilibrium. So N is equal to P. Okay. So putting N is equal to P, we can find out the elongation and we will get PL by A. Okay. But in this question, the area A, cross-sectional area A, and the internal axial force N vary along the height of the cone. So we cannot use this formula. We have to first find out the amount by which the element is shortened, and then we have to integrate it. Okay, so area A and internal axial force N vary along the height of the cone. So first we have to find the shortening in length of element and then integrate it. Okay, so at a distance zeta from the base, we take an element d zeta, and the weight will be acting as a load on this element d zeta and will try to compress it. So the internal axial force will be the weight above this element will be rho g into volume of the cone above the element. Rho g can be written as W, and this will be volume will be 1 by 3 area of base into height. Okay. So the shortening d delta of element of length d zeta is shortening d delta of element of length d zeta is given by this. D delta is equal to n of zeta d zeta upon a of zeta e. Okay. And deflection at any location x can be given by integrating the above term, integrating 0 to x n of zeta d zeta upon a of zeta e. So deflection at any location x along the cone can be given by this formula. Now this deflection at any location x can be also said in another way, that is total shortening of segment of length x. Now what does it physically mean? If we take an element of length x, okay, so the amount by which this segment will be shortened will be the deflection at that x. Okay. Okay, now let's find out the deflection at point at mid height. So we will use this formula to find out the deflection at mid height. Putting the value of n of zeta w into 1 by 3 a of zeta h minus zeta d zeta upon a of zeta, cutting this two. Now on simplifying we get w by 3 integration 0 to x h minus zeta d zeta. On integrating we get h zeta minus zeta square by 2 limits 0 to x. So finally we get deflection at any location x is equal to w by 3 hx minus x square by 2. So with this help of this formula we can find out the deflection at any point. Let's say if next year it is asked to find the deflection at x is equal to 3h by 4, then it can be found out by putting x is equal to 3h by 4 in this formula. Okay, so we have to find out the deflection at mid height, that is x is equal to h by 2. So it will be w by 3 h square by 2 minus s square by 8. So it will be wh square by 80. Okay. We can also find out the deflection at point C. So putting x is equal to h, we w by 3 h square minus h square by 2. So it will be wh square by 6e. Deflection at base point A can be found out by putting x is equal to 0. So it will be 0 because this point A lies on the support and support won't be moving. The support won't be moving, so deflection of point A is 0. So I hope this video helped you in some way. If you like this video, then please like and subscribe. Thank you.